For our water rocket project, we decided to adopt the Gardner-style quick connect system. However, we found that this method had many complications behind it. This method is a good example of how to never judge a book by its cover, because the simplistic looking launch platform masks the underlying technicalities and complications in assembling it, which directly affected our rocket design. Many other small flaws in the components we used also directly resulted in the failure of our system, which we will later describe in the video. We chose this method because we wanted an intuitive, compact system that could adapt to both vertical and angled flight easily, and a system that could theoretically withstand more pressure than most systems found. However, this was easier said than done. We assembled the system by using various tight-fitting PVC pipes, which are listed in the description and the document below. We used a hose coupler, a PVC end cap, strings, and a tire Schrader valve. We glued two PVC pipes to a 90-degree elbow and sealed off one side with an end cap, and the other side is fitted with a hose coupler. On the end cap, we fit a Schrader valve through to provide us with an easy way to connect the bicycle pump to it. We secured this assembly to a plank, which is then connected to another plank with door hinges, allowing us to easily adapt our launch platform for angled or vertical flight. We attached screw eyes adjacent to the assembly and glued two strings to the hose coupler, allowing us to release the rocket with the pull of the strings. For the rocket, we used sheets of plastic to make basic fins and a nose cone attached to 1.5-liter Coca-Cola bottle. Then we attached a male-ended hose connector to the opening of the bottle to now allow it to connect to the hose coupler. We created two parachutes using trash bags and yarn and stored it inside the cone. This gives us a rudimentary parachute for the rocket. Operating our system is simple. Just fill the rocket one-third the way through with water, plug it into the hose coupler, connect the bicycle pump to the assembly, and pump until pressure is built up in the rocket. Then, we launch by simply pulling the strings attached to the hose coupler. Our system ended in failure due to an unforeseen incompatibility with the parts we used. One such problem is with the hose connector attached to the bottle. Due to the differences in the threads between the hose coupler and the bottle, the nozzle is put at an angle, directing the thrust sideways instead of straight up. Having differing threads between the hose connector and the bottle created an even bigger problem than just directing the thrust sideways. See the problem for yourself. To fix this major flaw, we would need a hose connector with the correct threading. However, this is not a readily available part, which means that we would need a 3D printer, something we did not have access to in the time frame of this project. Our design ended in failure on the project day, but we as a team were able to analyze and diagnose the flaws of our design, which boiled down to the differing thread problem described earlier. We believe that if we had access to 3D printing equipment, we could have had a more successful system. Regardless, we had fun and learned a lot by putting our critical problem solving skills to the test with this project. Thanks for watching.
So,